GM, GM, everyone, and welcome to yet another episode of Solidity Fridays, where a couple of us sit around and, one of us sits around and makes keen comments about Solidity, and then the other one actually makes some keen commentary about Solidity and all of that. Today we'll be looking at 0xSpits, which has split off from Mirror and is a protocol for splitting payments. So if you have, say, one Ether that you're paying out, but it's going to a few different parties, what it does is it splits it out to a few different groups there. Before we dig into that, I actually wanted to take a minute for something that I don't think we've ever actually done to talk a little bit about the stream. Solidity Fridays actually got started as an internal thing in Linum Labs. So you may have noticed the Twitch channel and the YouTube channel that these streams are on is from Linum Labs. Linum Labs is a Web3 dev studio. So basically, a bunch of front-end, back-end, smart contract devs, dedicated design team, and more. And we take client projects and build them out. So we discovered that reading code on the smart contract team was just really, really integral to keeping up with Solidity and seeing what was going on there. Originally started as a bit of a guerrilla internal thing because the tech lead at the time actually wasn't very into it and refused for it to happen more than once every 2 weeks. So we kind of kept it as this guerrilla protocol review kind of thing. But then it eventually turned into kind of a set week, every Friday we would pick a protocol, we'd read through it for a while, we'd see what we can find, talk about what we'd learned from the code. And then eventually had the idea of even kind of streaming it out. My personal feeling, and this was one of my big motivations, is I feel like there's very, very good material out there, Patrick Collins or others who have incredible tutorials on how to build something. But one of the things that you don't get out of a tutorial is people actually struggling with code, hitting a new code base and not knowing what's going on and not really knowing what they're looking at and figuring it out on the fly. A tutorial is and should be polished. You don't want to see somebody sitting there trying to figure out how to make the thing for an hour. That's your job when you're doing the tutorial, basically. So we thought that there was a good place for this and have actually been humbled by the positivity for the streams. In the way of the world, as it happens, all three of us, so Ben, Rory, and myself, are no longer at Linum Labs. Rory is with Thea, a blockchain dedicated to gaming, if I'm not mistaken. Correct me if I'm wrong there. Ben is with Aave, and I'm with Polygon. We've kept the stream on Twitch and on YouTube by Linum. They've graciously allowed us just to keep on going afterwards. One of the reasons why I am mentioning this is being that none of us anymore are at Linum. There is the potential that there might be some changes in the future to what's going on here. Essentially, they are just letting us run around with their Twitch and their YouTube here. And I figured that it was worth saying just a little point about that, where we came from, what's going on. Our gratitude to them for all the time that we were in Linum and for continuing to allow us to put this stream out. And with that as kind of an overlong introduction, let's dive into 0xSpits. So do you have anything you want to kind of open up with about splits, Ben?
No. Well, we just found their site and we stumbled upon this just before starting the stream. So yeah, let's dig in here on the site.
There is one thing that's interesting to me that maybe I would just open out with, which is the whole protocol, something like 0xSplits. This is actually something that Bitcoin does very, very well. And I think one of the huge differences between UTXO and kind of the Ethereum state machine model. I mean, basically, anytime you have a transaction on Bitcoin, so let's say you have one Bitcoin in 0x1, let's say, and you want to send half a Bitcoin to 0x2. So the way that looks on the ledger in Bitcoin is you'll have an input, and the input will be 0x1, 1 Bitcoin. As in, starting in this block, 0x1 had 1 Bitcoin. Then in the output, it will have 0x1 half a Bitcoin, and 0x2 half a Bitcoin. Let's just assume that 0x2 didn't have anything in it before. And every transaction works like that. So essentially, any Bitcoin transaction is a split. That is basically what UTXO is. It's actually the exact same if you're splitting to somebody else, if you're splitting to a bunch of people, if you're not leaving anything for yourself, if you are leaving something for yourself, it's all going to be that same kind of pattern. You have the sum total amount going in on one end, and then all of its destinations on the other. I recently saw a transaction coming out of FTX. I seem to remember had over 900 output addresses on one transaction. So it happens to be, so this is something that UTXO does very, very efficiently. Just with the way Ethereum handles blockchains and like the EVM, so it gets a little bit harder, it gets a little bit more gas intensive, but I just feel like it's an interesting thing to know about coming in.
Yeah, I think that's an interesting comparison to make. I had like a very rough, vague concept of how Bitcoin handled it and how Ethereum was different and not as seamlessly, well, not as kind of natively splitting at the primitive level. But yeah, I think there's definitely in Ethereum land, like that's where we have all the DeFi and all the other like composable, more expressive things built on top, obviously because of EVM, and Bitcoin not so much. And so this primitive seems useful.
Oh yeah, for sure. I'm definitely not trying to take away from it. Yeah, 100%.
Like this is an interesting primitive. Basically, is what we're getting at to start combining into the land of DeFi on Ethereum or on any EVM chain. Yeah. So just going through the site here, I'm not sure what the user flow is here. Well, so do you?
I seem to remember they actually, if you want to do live fire, I am pretty sure if you go to 0xSplits.new in a new tab, that they have something set up there. Like literally, like yeah, 0xSplits.new if I remember right. I'll try and find it. Oh no, it's split.new. It's split.new. My mistake.
Split.new. Okay. I mean, I've got just like a dummy test wallet connected, so I don't think there's anything that can actually split.
It does look like you're on mainnet though.
Yeah. Okay, cool. So, that's quite nice that you can import a CSV of like recipients. So you can pull in like potentially thousands of addresses just in a CSV file. You don't have to do that manually. And then you need to split. Your splits need to add up to 100% of some sort of flow or nominal amount.
Like that bar at that on the bottom, the 0% to 100%. This is good UX.
Yeah, great for like, it would seem it's more just a standard primitive, but I guess it's like also very user facing. I might compare this to something like as primitive as like ERC, what's it, 2646, like yield bearing vaults, I believe.
4626.
4620. No, isn't it? Yeah. 4626. Right. You're right. Yeah. But here, I mean, it can be so like consumer facing as well. So that's quite interesting about it, is that you can start combining it like deeply within the DeFi ecosystem, but it's also like you can just as a user just go and play around and like plug in values and set up your own splits. What's this distributor fee, Will? So this fee incentivizes third parties to distribute balances on behalf of recipients. Basically, you can set your own incentive here. And so as money flows into, I believe, like a contract that's created.
Yeah. That sounds right. I see where you're going with this. Yeah.
That's really interesting. I think that's super innovative.
It's almost like a built-in gelato.
Yeah. So like some economic incentive for automation happens that some amount what you set here is set aside and can be claimed if someone goes and calls like a distribute function and distributes the money held in this contract to the actual recipient, so they don't have to come and call those functions themselves. So that's quite interesting.
Something a bit strange to me here, though, which is there's something that's not working out for me mathematically, which is if you're leaving a distributor fee, why wouldn't you just distribute it yourself? Is it because you assume that a distributor will know how to game the gas better?
Yeah, I guess like that long tail MEV vibe, where like if you just want to like pay people or set up some sort of like payment thing and like forget about it, like
does this allow that though? That's kind of what I was missing. Like this doesn't seem like a stream. It seems immediate. Is there like also a time at? Like it'll only happen at a certain time? Because like that's Gelato's big case is like, let's say there's a transaction I want to happen at a certain time, but not yet. So then you can integrate with Gelato or something like that, and one of Gelato's users' bots will hit it at the right time for a fee. Over here, though, if it's supposed to be distributed immediately, I wonder. Unless there is some kind of, like, I'm not seeing anything here for a delay. You know what I mean? Like a monthly or whatnot.
I don't think it's time sensitive. I think money just flows into the contract, and it's not necessarily a stream. So, like, if you were to combine this with Superfluid, which I think you could, I mean, we'll get into the contracts now, but I believe you would have to like call something to actually realize that transfer of value. So there's ERC20s or ETH or whatever sitting in the split contract, and then you'd be able to distribute.
Yeah.
I guess like
interesting. I feel like I'm missing some of the use case here. Like I'm absolutely positive that if they put that in there, that they have a good, like they found a very practical use case for it. I just feel like I haven't fully gotten it yet.
I think it's just for UX. I mean, like you could just, set some small amount depending on how much money you expect to flow into this, and then you set it and forget about it, because like also, if you're creating a contract, it's probably going to be like recurring flows into it. It's not just a one-off. I'm assuming it's like you're not assuming it's not just a one-off like flow of cash, like once-off payment of like 2 ETH into this contract. It'll probably be like a monthly thing. Yeah.
And
so then it's better like if you're like not the most technical user who's going to like run some sort of like Foundry transaction through the Flashbots RPC, you can just set this fee and just forget about it, I guess.
Yeah, I hear that. I mean, get as a way to get it to non-technical users, or if there's a non-technical, like, or at least a less technical sender. Yeah, I get what you're saying there.
Yeah. And then this last option is interesting, mutable. So you could add, is the idea that you could add more recipients, and you could change their shares as well. That's interesting. So then you would have an owner account, which could be a multi-sig. And I guess you can then reconfigure who's getting what. Not bad. All right. Well, are you ready to dive into the code?
Yeah, let's do it. I'm just also eating breakfast on the side, so that's why I keep on muting, so you don't get all my chewing.
What's for breakfast?
Roll with salmon spread, man.
Nice.
Breakfast to champs.
Breakfast to champs. Breakfast to Twitch streamers.
I think that's Monster beverages.
Well, one day, guys, we'll turn on our cameras and you'll see the heinous amounts of Monster and Red Bull we chug as Twitch streamers, professional Twitch streamers. All right, into the code. So
you're on the tests, man.
Am I? Okay. Okay, so here we have splits contracts. It's in we noticed it was in a hard hat repo, not Foundry. And if we
still like hard hat, I'll be honest.
Sure. Same.
Controversial take. Yeah.
I think honestly, like I've gone back and forth on both of them, and and now I just sort of appreciate them both for different
Yeah.
things. I'm still
Need to
watching.
get into Ape.
Sorry,
I need to take the time to get into Ape, I think.
I haven't played around enough with Ape, and I've got like some
Yeah,
really
me neither.
cool Ape shirts from East New York that I've been wearing around advertising. But yeah, Ape looks really cool as well. And I'm a bit of a Python fan. I know that's a controversial take with some of our people in chat, Mr. Ryan. Um, but yeah. Okay, so here's the repo. We're gonna dive into contracts. Let's just take a look what's in there. We have interfaces, libraries, split main. This is interesting. Split main.t.sol ignore.
That is Foundry. That's a Foundry test right there.
Yeah, interesting. I thought
maybe it was a hybrid repo. Maybe I missed that.
Could be. Here's the
I
hard
don't
hat.
see the foundry.toml.
If we go down here, yeah, I mean things are hinting at a hard hat environment.
Yeah, but that is like pure Foundry test or DAppTools. I mean, could it be DAppTools? I don't even remember how to check if something's DAppTools right now.
I mean, I don't know what we just came across here. Maybe it's not a relevant.
But it is DS test as opposed to Forge STD. Like Forge has already moved on to Forge standard library as opposed to that. But yeah, I don't know. Interesting.
Okay, so I guess our entry point is split main. Well,
yeah.
Let's do that. Split main.sol. Are we on it? No. Again, tests hard hat config. Split main.sol. Lovely. And as we jump in, we see some gorgeous art. This is becoming, I think, if you want your repo or your DeFi protocol or whatever you're doing in Solidity to pop and gain attention, you need to put some effort into the ASCII art. Like this is some good stuff. You need to compete.
I'm waiting for OpenZeppelin to do this on like Reentrancy Guard, which has 5 lines of code and have like 300 lines of ASCII art and like 5 lines of Solidity. It's the way to do it.
Which was it? I think it might be Yield.
Zora?
Was it? No. Yeah, I mean, Zora has great ASCII art as well, but I think Yield has one where it's like this whole, maybe it's Yield or something else, it has like a guy holding a sign. It's like tells a whole story. There's a narrative like going on. It's like a comic in the ASCII art. Of like what's going on in this contract. And I want that.
Zora had like the whole user interactions thing. They would have like user interaction tables in all of their comments.
Yeah, but
it actually really impressed me. I actually really liked that.
Yeah, I remember they had some great stuff. But I'm thinking it was just like such memey ASCII art from the one I'm thinking of.
We're rebranding to ASCII Fridays, yeah.
ASCII Fridays. We've done Yule Fridays. What else did we do? Viper Fridays. Now ASCII Fridays. Maybe Huff Friday soon. Who knows? Ooh. Okay, cool. So we did notice that this file is 850 lines long, and half of that seems to be taken up by ASCII art. So let's jump in. The errors.
Errors outside the contract. I'm actually starting to become a fan of this pattern of putting things like the structs and the errors and things like that outside of the contract.
What's the benefit of that?
It makes it cleaner for importing into other files. I also kind of feel like it lets you read the contract more cleanly. Like even for readability, I'm really coming around to it.
Yeah, fair enough. All right. We skim past that. Okay, so here's a struct that's also outside of the files, as you've noticed. Split metadata. So it has a byte32 hash.
Ooh, I like this setup. Yeah. Which I'm assuming is the identifier.
Probably, yeah. The controller, and then a new potential controller. That's interesting.
So that's like kind of that V-curve setup. At least V-curve is the first thing I remember reading that had a style like this, where like anytime you're updating any of the big addresses or rates or anything like that, basically you have the rate, then you have like the next rate in the queue. And so there's no way to directly change the rate. You have to put one rate in the queue, and then from there you have to like take it from being on deck into being the actual rate. And I think at first, like when I first saw it, I couldn't really understand what the big deal is. But I mean, there's really, I think, two major advantages to doing things this way. One is that if your protocol has a time lock on affecting major functions like that, so even if someone maliciously compromises the system, it buys you that much more time. Because if it takes 3 days in time lock to change the rate, so then you have the extra 3 days right there, or whatever the case is, because they have to get it on deck and then they have to set it. The other thing is, and this is the reason that I actually really didn't believe it first, but the more that I'm around there, like the kind of more I think about it, is in case of errors. There's that much more of a chance someone picks up the error if it's on chain. So if it's the wrong address, who was that? There was someone within the last half a year who accidentally set the wrong address for something. Oh, and there was the whole optimism thing. It was optimism, right? With the guy who ended up deploying like 300 Gnosis safes to get the funds. So if you have one of these like backstops, it's just that much more likely that someone runs a simulation, that somebody checks it another time, whatever the case is, you've given yourself that much more of a chance someone picks up on the error before it goes live. So I've actually become a much bigger fan of this pattern.
Okay. Yeah, I hear the arguments. Interesting. I mean, the counter argument is, of course, that it takes up a bit more gas and storage space. So there's some costs involved in it, but yeah, trade off for
extra transaction. Yeah, for sure.
Yeah. All right. So now we go down into the storage. Right. So we have a percentage scale. Okay, that's interesting. So this is their scale variable basically, but it's basically what 10 to the 6. Whereas, I mean, previously I've used two different scales. I've used either 10,000 or 1E18, which is common with the decimals of an ERC20, or the most common decimals of an ERC20. So it's interesting to see 10 to the 6 here.
Don't like USDC and USDT much, do you?
I mean, I don't know. Like six decimals, it's so arbitrary. Wait, does Bitcoin have 6 decimals? Where does that come from?
No, Bitcoin is 18.
Really? You sure?
If I remember right. I'm sure. No, I just said that with a lot of confidence. It happens to be, but I'm pretty sure it's 18.
Yeah, you're right.
I think that's where ETH got it from.
Eight. Only 8.
8?
Yeah. I thought it was like a weird small amount like that. Yeah.
Oops. Man, I was sure it was 18. Well, that tells you how accurate I am when I'm sure about things.
Yeah, so there you have it. That's their scale.
I think USDC is also 6. No, I think the financial world might use 6. The traditional financial world. I think it uses 6 for those things.
You're saying for calculating fractions of cents.
Yeah, like interest and things like that.
Yeah, I can believe it. Okay, interesting. And we see that there's also this max distributor fee. Is that, if we go back here, where is it? Gone. Yeah, distributor fee. So you can, the max here is...
Shouldn't be able to go over 10%.
10%, yeah. I can't do more than that.
Yeah, you can see, yeah.
20, like, whoop. 20. No, yeah, I can't. The UX, or the UI also restricts you to 10, which is good. Interesting. And then address of wallet implementation for split proxies. What's going on here, Will?
Not 100% sure. It seems like the split maybe is tied.
Wait, I did see in the repo there was...
Yeah, there was a wallet. There was a wallet contract.
Split wallet got solved. It might have something to do with this. Yeah, not a huge contract, I guess. Should we go into this now or just keep going here?
I'm assuming it's some kind of destination contract, like this is where the funds get held.
Let's see.
And like where people will withdraw from.
It can receive ETH. It can. And there's an only split main, which is I assume, yeah, that's the split main contract. Only split main can pull some stuff.
Uh-huh.
Send.
I'm guessing. Yeah, I'm guessing each split main creates a split wallet, and that we're going to see some delegate calling between the two. But I'm not. I'm not like 100% sure about it.
Yeah, doesn't look like a lot's going on in here. It's just, all right. Let's see. We'll maybe get to that later. But that's I assume that's what this is, the wallet implementation address. Cool. So here's some more variables. We have ETH balances for each address. And we have a similar thing for the ERC20s. So for ETH, obviously, it's just ETH, which is stored in the contract or held in the smart contract. And so we can map from the recipient to their amount. With the ERC20s, these balances are also, they would be recorded. The balances of each token would be recorded in that token's contract, but they would only point to this. Probably
this contract as the owner.
This main contract. So here we have to internally keep track of which recipient. It's a given token. Let's say USDC or DAI. Which recipient in this whole split system has which balance.
It's actually, now that I think about it, it's interesting to me that all of the balances are being individually recorded, as opposed to just having shares and figuring that out on the fly.
That's interesting. Are you saying like for each split like configuration, so one of these, you should just have shares?
I would have thought, like, that's kind of the classic method. I mean, because if you think about it gas-wise, what that means is, let's say I send 100 USDC to the contract. So it's the difference between one right of just changing the owner of 100 USDC on the USDC contract to needing to write in the split. So now Alice has 20 and Bob has 20 and Carol has 20, etc.
What the trade-off I think comes in is if you're a recipient of like let's say 10 different split contracts and you're getting like DAI from like 10 different directions. So you would have 10 different sets of shares across those, whereas now it would just be all pouring into one DAI balance here.
If that's possible, I hear. Oh, okay, I'm not sure I understood that's how it was working. I think I get what you're saying. Yeah. Okay, yeah, I think I get what you're saying.
Or is this, I mean, so that makes sense, but is this actually, is one of these, I think maybe I'm wrong, is one of these split main contracts created per split? And then my argument wouldn't really make sense.
I'd originally thought so, but yeah. I'm not sure anymore. I think we need to find out.
Yeah, I think actually maybe it's the latter. Maybe you're right. So maybe the shares thing starts to make sense. Yeah. And as you can see, then there's also this mapping of for each like recipient, they have some split data, which we've defined up here. Cool. Then there's some permissions specified in modifiers. Will, do you want to, should we kind of skim past this? I'm worried we're going a bit too slowly here.
Oh, I was, yeah. I was mic'd out there. Yeah, we could do that.
All right. Create split. What's happening in here?
So I'm actually starting from the NAT spec here. I see what you're saying. It looks like you can support multiple splits through split main, whatever that means, which goes back to what we were just talking about. If you can have one address that is receiving from different splits with different percentages, I totally understand the mappings for, like, tracking the specific balances of accounts as opposed to just because that allows you to have the granularity of receiving different amounts from different splits and having all of that unified in one place, as opposed to needing to pull out from a number of different payment splitter contracts or something like that. So over here, like, it actually seems pretty straightforward. You get an array of the addresses that are being split out to, an array of how much each one is receiving. So that's kind of like zipped together, as it were. Like index 0 of accounts will correspond to index 0 of percent allocations. UN32 distributor fee, and the controller, who's going to be like the owner of this split. External override. I guess they're using an interface here. Valid split, I'm assuming, is some kind of validation. Probably just making sure that like accounts and percent allocations are the same length, and the distributor fee is less than the max.
I think, yeah, I'm assuming this adds up to 100 as well, 100%, right?
Oh, yeah, good. I wonder if they'll check that, actually, being that it is a state-changing operation. I wonder if you'd validate that beforehand, because it's just like, that is going to be like a for loop and some summing. I wonder.
Let's go check it
out. It depends on the one reason I would say that maybe is it depends how the logic is implemented. If it would turn out that if you put in more than 100%, that like you would be able to spend someone else's funds or something like that.
Yeah.
So then I would definitely understand putting in a validation first. That's the split hash. Seems to be a different one.
Here we go. So here we have this unchecked block with the for loop.
Yep.
Huh. Yeah, get some percent allocations. Okay, so we do some things. We do some things. Interesting. Maybe we should have gone through this valid split.
Percentage scale. Yeah. I think it is worth going through now.
Yeah.
So if account's length was less than 2, it's interesting that they check that. So then it reverts. If accounts.length is not equal to the other lengths, then there's a mismatch. If get some percent allocations is not equal to percentage scale. Oh, because it's sums, so it should all equal 1e6 precisely. That makes sense. Then we hit unchecked. We get the length. UN 256 I equals 0. I less than loop length I plus plus. If accounts I is greater than or equal to accounts I plus 1. Oh, so they need to be sorted. That's interesting. The addresses actually need to be sorted by value. That's line 205 and 206. You can't put 0 as an amount, so that's also a validation. And then there's percent allocations. Yeah, sorry.
Order would be able to. I mean, you could definitely sort it on the front end, and I think that's trivial.
Yeah. I guess I'm just curious why they need it. I'm assuming it's going to have to do with the paying out. Like, there's probably an optimization that they can get there. It's just interesting to see.
Or I wonder.
Access validated.
So yeah, that's super interesting.
Equals UN 32 0. If percent allocations length UN 32 0. Check there.
Chat, do you have any idea why the accounts, in your splits, why you would need to put the cut that everyone's
getting.
Addresses
sorted by value.
Yeah, why would you have to sort that in order of like cut that they're getting?
Oh wait, it's the addresses, I think. I think it's the actual value of the addresses if you take them as an address. I don't think it's the amounts. I could be wrong. The amounts also needed to be sorted?
I don't know. I was just going with what you were saying. Accounts.
It's actually the accounts. It's the actual address.
Okay.
The addresses are being sorted. I'm assuming there's going to be some kind of optimization there.
No, you know what it is? It's probably for hashing to get a predictable hash.
Wait. That shouldn't be the case, though. No, I mean the hash should still be unpredictable no matter which address it is. No. Oh, I get what you're saying. To be able to reconstruct the hash, you're
Yeah.
saying,
So
like you'll know that the addresses had to be in this order, so you'll know that that's the order you need to put them in order to hash. Yeah, I get what you're saying. That makes sense.
So I mean, where I'm sort of getting that idea from is Uniswap v2, where the factory contract would create a pair contract of two assets, but to have a predictable, you'd be able to predict the address that pair contract would be deployed at, because it would sort those
Sort
two,
the addresses of the pair. Yeah.
the two addresses of those two tokens in the pair in alphabetical order, and use that in the create two. Or create two. Yeah.
Yeah, create two.
Yeah.
I can't figure out 211 and 212 though. I can't really figure out what it's validating there. Like, shouldn't that already have been validated in the loop?
Allocation.
Like, it's checking if the last percent allocation is 0, no?
Overflow should be impossible.
I should have already done that, I would have thought. Where are you checked for mismatch? Like, if it was to check for mismatch, I'd get it. But, yeah, I don't know. I don't know what's going on in that one. And then it checks to make sure that the distributor fee isn't larger than the max distributor fee. Yeah.
Cool. Okay, so back to this.
Yeah, back to business.
Right. So there we go. You're going to get, or you do hash split, which is all of the accounts, which that's why they would need to be sorted. So we just check that they are sorted. Percentage allocations and the distributor fee. That's going to give you your bytes 32 hash, which is, I guess, your identifier.
And theoretically, this should be collidable, so to speak. If two people want to pay out the same amount to the same people with the same distributor fee, you should have a collision. It's interesting to me that there wasn't like an additional nonce like block.timestamp or something like that.
There might be in this hash split, right?
Oh, good point. Good point. We're not actually seeing the hashing there. Yeah, good call. Except that, no.
It's not.
Yeah.
Well.
And they put it in memory there.
That, I guess, makes sense. So the only way you could get a collision is to have the same accounts with the same percentage allocations and the same distributor fee. And if you're getting a collision, like...
It is, yeah, I agree.
You should be
it sounds pretty out there.
Well, no. You like, then you should just be reusing that contract that you've created, because it's the exact same people getting the same cuts.
Right, but it doesn't look like there's anything in the code above to handle that, like checking if there's code there or anything like that. I think it'll just throw an error when it tries creating the contract there, because it's already going to be code there.
Right, yeah. I mean, maybe it would be...
Could that have been, in this hash split function, could those have been call data? Is there an issue passing call data through an internal?
It might be because they're coming in as memory from the...
Yeah, I was wondering that also. But I think they're call data above. Yeah, they are.
They are, hey. Huh.
I wonder. I have a suspicion there's a reason why they're memory, not call data. I just don't know what.
Yeah, I don't know why either.
Oh, so this if controller equals address 0, I think that is actually covering what I didn't think it was covering before I actually looked at it. It's trying to see if there's already somebody controlling that split. And if it's not, like no one's initialized that, so then it does clone deterministic.
Oh no, so this is the setting here, the mutable one.
Oh, you're right. You're right. Whoops.
So that's if you want someone to be able to like modify and change those splits in the recipients later on, then you would be able to put in a controller address, and it'll set you up with one of those splits. Otherwise, it'll do one that's immutable, that there's no owner, and you can't change those things. And there's probably some gas optimization that you can do in one of these as well.
Interesting.
Yeah. Right, and then we store that split hash.
What's that wallet implementation thing? The first argument in clone deterministic, or just the regular clone? Is that that whole contract? It's
That's
probably
this.
just the code hat.
That was
It's probably the
defined
code from that
here.
whole contract, isn't it?
That's this address wallet
It's
implementation.
an address.
So it's a global address.
Oh, it's taking the code from there.
It was this thing. Where is it? Yeah.
Clones is in libraries, I think.
Or we think it's this split wallet.
Yeah, we think it's that, but I'm saying like I kind of wonder what the function's doing with it as well. But yeah, it's a big tangent. I'd say we keep on going over here.
Yeah. Where was I? Am I in the right spot? No. Yeah. Okay. Back down. Cool. And then we store. This is interesting. We store. What is a split? That's the whole struct, right? Yeah. I mean, this split is, I think, a whole struct.
Yeah, it was there at the top. It
Oh,
was
no,
the
sorry.
hash and the controller and the controller on deck.
Sorry, no, it's just an address. The split. So we have that address.
Oh, I see what you're saying. I'm okay. I misunderstood what you meant.
The address of where that split contract is deployed to, and that yeah, we store that hash in that mapping.
Oh, and I get it on on line 274 and on line 277, that's being returned as the address, and we've already declared it as an address in the returns line on 265. Yeah, okay, I get it.
Yeah. Cool.
Yeah, this reminds me of I think Soulmate would also throw these in. The truth is, the create two factors I've seen also do, where there's just like a view function that allows you to predict what the address of something will be. This is really useful for testing. Like, let's say you want to test this, you want to make sure that things are actually getting deployed on the address that you think they will. So then in the test, you can hit this function first to figure out where you think it should land, and then assert that it did actually land there.
Yeah. Makes sense. I mean, so what are we reverting on when we actually do collide with that?
I'm pretty sure that's going to be an EVM level throw. That it will, if I recall correctly, the EVM will not deploy code where code has already been deployed. So I believe you're going to get an EVM level revert with that reason.
Yeah. So, well, I mean, we never check it, right? Yeah. So we say hash split hash, and then we don't do any checks on the split hash that's like actually been, stored or created before.
Yeah. Which, just to be honest, from a Solidity perspective, does not bother me all that much. It's just it's an interesting choice, though. Like, you can see a lot of work done on a lot of things to make sure things like this don't happen. That being said, it's usually in cases where someone has a financial gain from being able to exploit it, like, say, permits. Whereas over here, there's it'll just revert and that's the end of it. So I can understand the choice to say we're not going to socialize the cost of checking for this really strange thing on everybody by making them pay gas for it.
I would probably lean towards that side of the argument, but I can see there's another argument where if you checked and then through a more readable error of hey, there has been this split that's exactly like yours that is already created, go use that contract to split up your money.
You'll need to determine the address beforehand, though. So basically what you're going to need to do is you're going to need to run that projection function before you've actually deployed, and then check the code size there. And then say, if the code size is greater than 0.
You could just read it off here, right? You could just read it off the struct.
By the time you're down there. But remember, you've already run clone deterministic or clone by the time you're down there.
No, I'm saying
you'd have to.
Here, if you were to do a check on this, that's.
Oh, that's just the hash, though. That's not the address it's going to end up on.
No. Yeah, I know. But you say
you have the information you need to determine it, but you still have to determine.
Yeah. But you wouldn't have to that's not cost. That's actually that's incurred if you are creating a new unique split contract.
Yeah, but you'll end up doing it twice if you're successful. You know what I mean? Like you check to see if the address has code in it first, so you have to determine the address, and then you actually do create two after that.
Yeah, I see what you're saying.
It's kind of the old question of like how much you protect users from mistakes at the expense of everybody who's doing it right.
And especially for something like that aims to be as primitive in a global financial system as the splits contract.
Yeah.
I definitely, I think, side with the argument of like minimizing the gas costs and optimizing efficiency as much as possible.
Mm-hmm.
And then, even if it's not necessarily that like user friendly on like the revert error level, as long as it's secure.
Yeah, I'll admit, I was kind of surprised they check for 0 percentages, as in it reverts if, like, it'll revert if someone put a 0% split to somebody. Now, I agree that a 0% split is useless, but at the same time, if someone put that in, you know what I mean? To some degree, it's their fault if they pay gas for it. But now everybody else has to pay for that check. I was a bit surprised they checked for that. It could be that there's additional reasons that I'm not aware of. Like it could be that's one of the like a double check on the arrays being the same size or something. I'm not exactly sure, but for that reason, actually, I was a little bit surprised they put in 0% checks.
I mean, one thing I can think of is that you could make it harder or more gas inefficient for someone to claim their money and put like, hey, I'm going to split this money with you, but I don't really like you. So here's also 10,000
Put 500 zeros.
Yeah. And now, like, good luck trying to claim your money because it's going to run that for you, dude.
Griefing. I hear. It's a very interesting idea. That is a very interesting idea.
Interesting that my mind goes to those solutions, eh?
We all need to think this way, because if we don't, someone who uses our contracts will.
Yeah. Oh, well. Sweet. Then there's this update split function for if you do have an owner of your split account and you can update it, and you just run this update split. Actually, that would be interesting to see how they gas efficiently do that.
Yeah.
Interesting that they call the same valid split thing again, which is fair enough.
Yeah, like whenever you update, you probably have to put in all of the addresses and all of the amounts over again. That would be my guess.
Yeah. Yeah. So that's actually that could be interesting code. Update split. Again. There we go. So again, what? You see this well?
Yeah, I'm looking at it.
So when you update the split, you're just
it redoes the hash.
It does the hash, stores the hash, but does nothing else.
Yeah. I don't think so. But I am a bit confused also.
What?
Yeah, how's that going to work?
What? I mean, how does it, store the updates?
Right. How does it know how to split it?
Yeah. Wait. Does it create a new address?
It didn't look like it.
Yeah, I didn't see
because
that.
the address remains the same in the split struct.
Wait.
Like the key to it.
Is it valid immediately after updating, only accessible via controller? So we call after we do the update, which is basically just overriding that go back down.
Original amount.
Yeah.
Or the original hash, I think you're going for.
Yeah, with the hash. Then we call distribute on the split that was passed in, this address.
Mm-hmm. Probably keep it as a destination, assuming that's where all the funds are going.
Interesting. I feel like so we're paying them out and maybe then creating a new thing.
But then it's going there? Yeah, so wait a second. We saw that there were balances here. So what's getting written to the balance here and what's going to the other contract? The element, like I'm still unclear about that.
Well, what's happening in this distribute ERC20? This is interesting as well.
Yeah, I think this is where we should be, yeah.
All right. So, okay, so we take the normal stuff, the address of the split, okay, specifically one token, which is also interesting, right? Oh, wait, I was looking at the wrong thing. Update and distribute. Is that what we were looking at?
That's how we got here. But the truth is, even just understanding the distribution logic, I think, would be useful.
This is what I meant to look at. Update split, which just calls this. But we did go through this, and we still are unclear.
Yeah, we weren't 100% sure how that works because only the hash is changing. Like, how do we know what the percentages are in the future? Not sure.
But yeah. Okay. So let's go back to what we were looking at, which is where were we looking at? Distributees.
Updated distribute ERC20.
Yeah. Cool. All right. So, I mean, we have in a given split, we're specifying some ERC20 token. We're passing in all the accounts and their allocations and a fee for the distributor and the distributor's address. This will obviously sort of just immediately, I think, take the cut, distributor to the distributor.
So the old trick about not zeroing it out is the unchecked block. They're always leaving like one way or equivalent, just so it's like not all the way to zero for the gas refund.
Yeah, that makes sense. Good catch. Interesting that we do this. We check the balance as stored here in our struct.
Yeah, things are getting stored in both places, which is actually like, we're not going to figure it out today, but I guess I really am left curious why some things are being stored here and some things are being stored in this other contract.
I think this might just be sort of a safety check that like what we have stored in this balance.
Doesn't look like it, but I could be wrong.
In the actual,
it could be I'm missing. Like it looks like it's actually two different things.
The proxy balance.
If main balance is greater than zero.
Right.
ERC20 balance is token split.
Also, how interesting is this? And maybe it's just their linter, but I mean, they write this if statement in line, and then this exact.
And that one, yeah, it's probably the linter.
Yeah. Huh?
Except that main balance is shorter than proxy balance. I don't know. Yeah, whatever. That's like a weird thing to I don't know. I'm gonna. My mind is gonna get spend way too much time on that otherwise. So I'm just gonna keep on going.
Yeah.
I might not know how to code, but I can make comments on code style. I'm not getting it this fast.
So my question, I guess, is why is there why do we keep track of these two things? As you've said, it now doesn't look like it's just for safety checks. It looks like
there are two balances.
I guess this balance. Yeah. Maybe it's the balance of this, like the split contract, split main, and then the balance, the other balances are attributed to the actual split implementation deployment.
Or if something got sent there by accident, maybe.
Yeah.
Like, yeah, I'm a little lost there.
Wow.
Um,
Huh.
and then it kicks it up from the proxy to main. I don't know. I don't know. I wish we would have found this function earlier. Like, this seems to be where like most of the meat is, and I'm dead. Like, my mind is just not getting it fast enough here.
Yeah. But this is always like the fun part, is going to like what seems like such a, simple primitive is just, splitting money. I think most like capable Solidity developers would be like, oh yeah, that's chilled. I can, throw up a contract that could handle these splits, robustly. But then you get into the code and you find like that there's so many like nuanced things to keep track of, like on the accounting side, on the gas optimization and security and validation side. And it's just like it's fun going down those rabbit holes.
Yeah, 100%, 100%.
But that's what we do on Solidity Fridays.
So, I think we're up on time here. So, been a pleasure. I wish we would have gotten that function before we hit time. But yeah, them's the shakes, as the prime minister of England, or once prime minister of England, said. So yeah, in any event, has been an absolute pleasure. Thank you for joining us for another episode of Solidity Fridays, and yeah, see you around the ecosystem, everyone.